3.1 three-dimensional space. Okay, that means 3D. Have looked several terms and let you understand clearly. The first one about the planes. Okay, and see part A, 3 non-collinear points. That means here we have several points A, B, and C. Okay, they are on the same plane. Okay, and 3 non-collinear points. That means these 3 points cannot use a straight line to join all together. Okay, a point and a line without passing through the point. That means here we have a point A and we have another straight line here. This straight line is not passes through the point A, okay, but they're still on the same plane. Okay, C, 2 intersecting lines. Here we have L1 and L2 and they intersect each other on this plane. Actually, any 2 lines intersect together, then they will lie on the same plane also. Okay, and this point is the intersecting point. Okay, if 2 lines are parallel, that means they will not have any intersecting points. Okay, so about the points and the line on the plane. Okay, let's have a look. Normal. What means of normal? Have a look at this. If a line passes through a point on the plane, and every line on the plane which passes through that line, then we call it is a normal of the plane. Okay, in other words, a normal of a plane is perpendicular to the plane. That means here we have this OP. OP is a normal. That means this one perpendicular to all the lines on this plane pi. We say that this one plane pi. Okay, and if I add another straight line, for example here, this one L3, actually this one also perpendicular to this plane, this line. I mean OP also perpendicular to L3. Maybe I draw one more about this one. Okay, L4. And this one also perpendicular to L4. Can you see that? Perpendicular, okay, to L4. OP perpendicular to L4. So we say that OP is a normal to the plane pi. Okay. The third term, C, projection. Projection. Okay, maybe I highlight like this. Okay. What means of projection? Let's say, if a straight line AB, okay, if a straight line AB perpendicular to the plane pi, okay, then AB perpendicular to any straight line passes through B on the plane pi. Okay, right? Just now they say that this one is normal, right? For example, like this. AB perpendicular to any straight line passes through B on the plane pi. Then have a look. Projection of line on the plane, that means here. if now I have a straight line L, okay, not on the plane pi, okay, it's just a straight line, then you think about, okay, this one, like, we have a light here, okay, and straight line L projected on the plane pi, okay, on the plane pi. So each point on the straight line L project on the plane pi will form this straight line L pi, okay, and we say that L pi is the projection on pi, okay. That means now if we have another plane, for example here, okay, and if you have one straight line here, straight line L, then perpendicular, 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 then this one L pi is the projection of straight line L, okay. Have a look one more term here, D. Angle between a line and a plane. Here is the line L, okay. If we talk about the angle between a line and a plane, the first step you need to think about the projection. It's really important. That means now L, for example, this point project here, this point project here, okay, project on the plane. So point A, then A pi here, point B, then B pi here, okay. All the points on the line L then project on the plane, and we say that this one L pi is the projection of L. After that, where's the angle between the line and the plane? That means here L and L pi, then you form this angle theta, okay. So this angle theta is the angle between this line L and the plane, okay. So here, angle between the line L and the plane pi is the angle theta, okay. Now we can have a look checkpoint 3.2 on page 7, on the page 7, okay. Later we goes on to have a look few more parts, okay.